Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 22nd, 2025, about 3 days ago. The striking bit is that this paper introduces a text-only auditory benchmark and a reasoning method called AIR-CoT that boosts models on key tasks, pushing pitch comparison to 83.89% and raising context reasoning to 71.55%. The paper is titled AuditoryBench++. Can language models understand auditory knowledge without hearing? And the implications for model training are quite significant. In short, it shows language models often lack auditory common sense, offers 5 evaluation tasks, and uses span detection with imagined tokens plus injected audio embeddings, while noting limited gains on duration and loudness. Also, the authors shared a GitHub repo for AuditoryBench++. Inside you'll find a concise README, links out to the dataset and project page, and a note that the implementation is accessible on GitHub, with code coming after review. No training scripts or model checkpoints yet, so watch the repo for the release. The repo overview was brief and promised code later. Figure 1 presents the benchmark at a glance, with text-only questions that probe pitch, duration, loudness, and animal sound recognition. The central robot with headphones signals imagination without audio input. The left panel asks which is higher in pitch, and the right panel asks which is longer in duration. The lower left asks which is louder, while the lower right highlights onomatopoeia mapping, as the word meow must match an animal. Well, Figure 1 sketched the tasks. Table 1 now summarizes the dataset composition in question formats. The table lists 3 comparison tasks with binary choice prompts, covering pitch with 3, 625 items, duration with 1, 645 items, and loudness with 445 items. Recognition targets animal sounds with multiple choice over 942 items, which probes onomatopoeia mapping. Reasoning focuses on auditory context with multiple choice and 75 items, so the corpus totals 732 question and answer pairs. Alright, Table 1 covered the dataset scale and formats. Figure 2 now lays out the AIR-CoT pipeline. The diagram shows data preparation that adds imagined tokens around spans needing auditory knowledge, so the model learns where imagination should occur. Stage 1 fine-tunes span detection, producing the imagined markers during decoding. Stage 2 performs knowledge injection, where the model pauses at the closing imagined token and pulls clap text embeddings projected by a small MLP to continue reasoning. Okay, Figure 2 outlined how AIR-CoT works. Table 2 reports what that approach delivers across tasks. The table shows strong gains on pitch at 83.89% and on animal sound recognition at 71.55%, and auditory context reasoning rises to 82.67%. Duration lags at 54.59% because the best baseline imagined to hear reaches about 58.78%. Loudness edges up to 59.33%, only slightly above the strongest baseline. Wrapping up, 2 takeaways stand out. The benchmark cleanly isolates auditory common sense in text, and AIR-CoT, with imagined tokens and injected audio embeddings, delivers sizable gains on pitch and contextual reasoning. The remaining gaps on duration and loudness signal a need for representations that capture time and amplitude. Thanks for listening. I am Alex, and this was the AI Research Roundup.